want to say welcome to everybody. Today we're going to be talking about ChatGPT. As a kind of introduction to so the whole thing is about, we need to talk about ChatGPT. I think, a lot of new faces. I'm assuming you came to talk about ChatGPT, so you know what or heard of what it might be. I'm not an expert. I'm not an expert in machine learning. I'm not an expert in ChatGPT in particular. It's just a topic that I'm interested in, and so it's something that I did some studying with, and I just wanted to share with you what I found. I'm not going to say everything is completely right. If you know something different or know more details of what we're going into, I strongly encourage you to participate and let me know. But yeah, let's dive right in. So normally at the beginning we'll do introductions and go around and talk to people and see what their backgrounds are and what brought them here. But there's a lot of you, so I'm just going to do a quick survey just to show of hands to see how many have used ChatGPT already. Okay, so a little more than half. How many have used the product of ChatGPT in work or in something that you produced other than for your own enjoyment? Oh, okay. What did you use it for? Just curious.
To debug.
Oh, to debug?
Yeah.
So you were able to give it your code and ask it, why doesn't this work?
Well, I just asked the Google question I would ask.
Yeah?
And I asked it to ChatGPT instead.
And how was it? Did it find the bug?
Not really, but it helped me to cover the bug.
Okay. So then would you say it's something that you would use again in the future?
Yes, definitely. I think probably would change the way of coding. So yeah, that's
okay.
Why.
Interesting. So what has been already said of this, and I think this is a kind of an interesting quote. It's not, I think it's a sensationalist quote. I don't think it's actually particularly accurate in any degree. But Paul, and I'm going to butcher his name, but Buchheit, said that within a couple of years, there may be a total disruption due to the rise of AI. I'm not sure what he means by total disruption. I mean, AI or machine learning has been around for the last maybe 30, 40 years, and we're still waiting for the rise of machines and for like society to break down and robots to take over, and it hasn't happened yet. And I don't know if it ever, if it will in our lifetime. Maybe it will, maybe it won't. So I think it's a little bit sensationalist to say that something huge is going to happen in terms of the way that we live our lives, but what total disruption means, I don't know. But there is a significant exposure to public, because I think ChatGPT finally allowed us as regular users to discover what's going on. What is this thing that they're playing with? How does this thing work? And how can I use it in my daily life and maybe in the future? So one of the questions I asked, just for fun, I'm not sure what I expected out of it, but I asked it, are you a good or evil chatbot? Not that if it was evil, that it would actually admit that it was evil, but it kind of gets to, I think, an example of what the answers to ChatGPT are like. And for the most part, I found them to be very I would say diplomatic, safe. A lot of, couching the response to make sure that that, hey, I'm a computer and I don't, I'm not the expert of things, so there's a lot of disclaimers, I guess, when it talks. The sentences themselves are pretty well formed, and it tries as much as possible to go back and make sure that the question I asked has been answered. So when I asked it, are you a good or evil chatbot? First, it starts with a disclaimer. As an AI language model created by OpenAI, I don't have personal beliefs, emotions, or intentions, good or evil. But we'll talk about that near the end of it. My purpose is to assist users in generating human-like tests based on input, blah, blah, blah. Informative and neutral responses to the best of my ability. It's interesting. But let's dive into what that could mean. So ChatGPT. So I wanted to at least start out with kind of playing with ChatGPT in general for the benefit of those who haven't been able to yet. So for the free tier, this is kind of what you can expect out of the interface. Essentially, there is some predefined questions that you can ask it to kind of give you an idea of the questions and the scope and the type of questions that you can answer, or type of questions you can ask. And then there's a prompt on the bottom. And the prompt at the bottom is where you type in your questions to the machine. And so I want to open it up to the group. If somebody wants to suggest something that I should ask the machine.
Can we make it through code? Because I have one.
Let's make it through code.
My students today built a tic-tac-toe game with HTML, CSS, and JavaScript.
Okay.
And we asked ChatGPT to do that.
Sure.
They're like, please, build. Yeah, we gotta be polite.
Please.
No? Hey, Minion, build me a tic-tac-toe game using HTML, CSS, and JavaScript.
Using HTML, CSS, and JavaScript. Any other parameters other than that? Does it
Make it colorful using pastel colors.
And aesthetically pleasing.
Yeah.
Okay, let's start with that, see what we get. So, right now is kind of the hour in which a lot of people in the Western world start to wake up, so there might be some traffic and some delay, but, oh, no, it's already started.
Can you zoom in a little bit, maybe?
Sure. So it is starting to generate the code, and those of you familiar with HTML can see that it's actually generating PHP code, but it's actually generating. Hey, along with PHP. Now it's slowly trudging along. Interestingly, it's almost like it's thinking. It's like taking time. It's not just like bursting it out. It's like pausing every now and then to think about like what the next line should be. But there's no typos. Right? You don't see a delete. Ah, maybe. So there's the CSS. Oddly, the PHP didn't actually contain PHP, but whatever. At least not that I saw. I think it's HTML. Nothing.
So it's interesting because when I try to use it to write Hangul, like it'll translate to Hangul for you, but when I try to do that, it timed out on me. But this it seems to have no problem.
I've had it time out on me before, and I just tell it like, "Can you continue?" And it'll continue. Or one time I just typed a question mark and it continued where it left off. Sometimes it does.
Okay. Yeah. So we're starting with JavaScript. Oh, it's didn't really get that far in terms of determining who's going to be a winner of this. It's just we could
keep prompting it. We could be like, the code looks okay, but could you please give me a function to determine the winner?
Yeah, but let's, before that, let's actually execute this code and see what it looks like. So I'm going to go to, let's say, CodePen or OneHub. It did
the HTML, CSS, and then the JavaScript. It actually split it up too.
So let's try it on CodePen, paste everything in, and see what we get out. Okay, start coding. Do I have to sign up for this? Definitely not. Not ready yet. So I will.
There's a copy code button at the top right.
Oh, how convenient. It's almost like it was made for it. Paste that in. Let's go back. That code.
Just was way quicker than mine.
Well, they don't have a check winner function at all.
I didn't have to.
But it's probably wrong.
Well, it's a pleasing color. There's a tic-tac-toe grid.
They got
Without borders, what?
And it looks like it's got an event listener for clicks, so if I click on things, it actually alternates between X's and O's.
Oh.
But, alas, doesn't yet determine the winner. So let's go back and ask it to. Include code to yes, code to determine the winner. So,
Oh, no, it's in the second again.
there now. So we'll see. Let's see how it goes. So, couple things to notice. One, we didn't have to re-prompt it. I didn't have to tell it, okay, this is what you got me before, and this is how to add on to it. In other words, it remembered the previous dialogue between the computer and myself, and I just had to add to the dialogue. And so that's something that's interesting, that it has aware of context, the semantic context in the conversation. So you can keep having conversations, and as you have conversations, it, quote unquote, learns a little bit about the conversation itself and what you intend out of the results. So, it's been really stuck on that TV. What is a square? 50 pixels.
I did the same prompt earlier, and when I first showed that into the browser, it didn't add any height to the squares, so it was just like 9 lines. So there you go. So I had to prompt it a few more times.
Here we go. Drum roll. So far, it looks pretty similar, except now there's actually a result thing. Oh, there's a check winner function. It's a check winner text. So it fills the winner function. Oh, here's the check winner function. Oh, nice. Okay, so it's checking based on what it knows as actual winning combinations.
Oh.
The horizontals, the verticals, and
All the winning combinations. So let's take the result of these. Paste it into there. And it looked like, since it did add it a little bit more, or at least added results in, let's see what the results would look like by also replacing the CSS and the HTML. And give it a second to run. It ran. So X and O, X and X, and X, and X, and X, and more X's, and no winner.
Jesus, ChatGPT, come on. I mean, you could argue that X is always the winner.
So not quite there, but yeah. Oh well. At some point, it
missing
lost the context for switchblade.
and check draw, and I think later there's check row that I never saw.
Oh yeah. Oh well. So anyway,
but the colors are nice.
the colors are nice. That's the same colors as before. Yeah. Okay. All right. Well, interesting introduction. So for those of us in tech, with W coding and code cell, pretty much right on. Any questions so far before we continue about what you saw? Okay.
Yeah, how do I build it?
Yeah. Well, here, interesting that you ask. So we're going to spend I'm going to try to keep it short. I'm not sure how many of you are actually interested. And so I'm going to leave it to you to give me some guidance as you ask questions and whatnot into how is this thing built. So I'm going to spend about 45 minutes now, I guess, or 35 minutes now that it's 7:25, talking about under the hood, not too deep, but talk a little bit about the concepts of how GPT was created, and hopefully then spend about an hour just talking about the implications, talking about what we can do with it, maybe try doing things with it like we just did. Try to keep it a little bit more interactive. I don't think you just want to hear me talk for an hour and a half about machine learning. Maybe you do. All right. Well, we do have to talk a little bit about it. So there's two parts. There's ChatGPT and what it's based on. So ChatGPT is a chatbot launch, blah, 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 but it's built on top of ChatGPT 3. It's actually built on ChatGPT 3.5, because ChatGPT 3 was actually built 2 years ago. And so it was actually a refinement on it. Instead of calling it ChatGPT 4, which apparently is going to come out sometime later this year, they call it 3.5. And so 3.5, which, surprisingly was apparently, they completed that in March 15 of last year, but they didn't open it up to the public as a chatbot until November 30th of last year, and then it just kind of gained momentum to where we are today in February, 3 months later, 3 months later, talking about it. So we're going to try to de-scramble some of these words for those of you who aren't familiar. So it's a family of large language models finely tuned, an approach to transfer learning with both supervised and reinforcement learning techniques. So we'll take some of those words and we'll try to parse them. Same thing with the text below that about ChatGPT 3, but we'll get to that later. We'll focus first on ChatGPT and then kind of peel back the layers of the onion as we go. So transfer learning. Transfer learning, in a very basic regard, is when you take the results of one kind of learning that you did and try to apply it to something else. So an example here in the sentence is knowledge gained by recognizing cars might be applied also to trucks. Trucks are cars, but it's a little bit larger and a little bit more misshapen, but they're cars. Right? Fundamentally, they have 4 wheels. They have a person who drives them, and they have headlights, and have a lot of the same common characteristics. So you could possibly find one and train it with another. Now, this is especially useful when you have the ability to take results from large models. Some of the big examples that we had even before ChatGPT were a lot of the image recognition models. MobileNet being a big one that also uses attention, which transformers use. We'll get into that. But the idea that you can take work that someone else has done with a lot of computers and a lot of money and a lot of time, and then we can use that to recognize pictures of cats on the internet. Mm-hmm. Right? And so someone has done a lot of this huge grunt work of trying to categorize and trying to recognize what's in a picture, and then we can take that and apply it to something very specific for our own purposes, whether it's recognizing marshmallows within our bowl of Lucky Charms or whether it's cats within our blog. We can take that generalized large learning set that someone had already done and do something specific with it. And so that's a really great advantage that we have with transfer learning. Supervised learning. So supervised learning is one of 3 classes of machine. Well, there's probably more as time goes on because there's been ones added on, but classical machine learning, we have what are called supervised and unsupervised learning. Supervised learning, essentially, we're trying to see how close to something a particular class or category is. So we start out with something a pile of stuff that we don't know, and then a pile of labels, and you run it to the machine learning model, and then tell it when it's right and when it's wrong. So typically you'll have the labels attached to the data, not necessarily always required, but as the training model goes in and it tries to hone in on exactly what labels, not the label here is misspelled, I just realized, labels, but what labels are attached to what data. As the model gets more and more sophisticated, then it becomes more and more accurate so that later on when it comes in with test data, then it can make good predictions. Supervised learning in this particular sense, the labels themselves, hexagon, triangle, or square. The model training, you can have different classes and categories and let's say parameters, hyperparameters, parameters. Number of sides, for example, being one probably very relevant one for this particular problem. And using that, it can determine something. It's very labor intensive on the part of the people trying to get the model to learn something. That's why it's considered supervised. Supervised in relation to the programmer who's using the model. Now, supervised is really good for things like how close are you to a particular classification that you want. So you have things like on the right side, supervised learning. Essentially, you have little dots, and you try to create a line that's as close to the line as possible, or minimize what we call loss. And so the distance between the dot and the line is our accuracy, for lack of, it's a very un-machine learning term, but accuracy, or is also called cost or loss. And so whether and how close we are to that particular line allows us to say how well our model has performed. Versus unsupervised learning, which is more of a little a generalization of clustering of particular things. It's really good at determining things that are similar to each other and clustering those into different categories. That's a very big generalization. There's also things like what's labeled and what's not labeled, but we'll get into that in a little bit. But the reason I wanted to bring that up is because in the first sentence, it says, approach to transfer learning. Okay, we learned that the ChatGPT is basically because ChatGPT has already been trained on this huge model of stuff, this corpus of stuff. In fact, in that second paragraph of the second part, gives us a kind of a description as to what some of that might be. They'd have 175 billion parameters, blah, blah, blah. Okay, so we didn't really get too much into it, but of that 800 gigabytes of data and billion parameters, it was actually taken from a whole boatload of training data. And there's another slide later on that kind of gets into what that is. But we are able to take advantage of that with both supervised and reinforcement learning. So we covered supervised, and let's talk a little bit about reinforcement. Reinforcement learning is a little bit, I would say, newer than supervised and unsupervised. Essentially, this approach has more to do with a reward feedback system. So instead of a bunch of data and labels, or data and hopefully some sort of clusters of, we can say clusters for now, also consider logics or vertices or whatever, but instead of that kind of approach, this one acts on states and actions. So these states here you can see as circles, the actions are kind of the arrows, but what state action to take at any particular time is determined by the rewards. And that's the R in this example diagram. And the point of the reinforcement learning is at some point you want to maximize the rewards. And depending on the parameters that you want to do, it may take different actions. But what those actions are and what those states are, we provide. But how it gets into determining what actions and states to go into, that's up for the machine to try to learn on its own. And so, for example, here I think we probably start with sleepy on the bottom left corner, and then we either wake up or hit snooze. If we wake up, it sucks, so it's a -1, but if we hit the snooze, it's kind of nice, so it's a reward of 1. However, that's a cycle that we have to keep repeating, and then we wake up. What we want at the end is to maximize reward. And if you take a look at the overall kind of, environment they call it in reinforcement learning, you'll see in the bottom right, the best reward that we're going to have is probably just 50 at the bottom right. You get a promotion at work. And so really on the grand scale of things, what do I have to do to maximize my rewards? It's probably going to include that 50.
I'm just going to read Twitter all day.
Yeah.
Or you can just spin around all day.
Negative. Work hard, ask for promotion, it's all negative.
But,
It's scary.
yeah, maybe it's scary, or, it's not something that you necessarily want to do.
I might read Twitter.
Don't go away. Don't wake up.
The rewards are a little weird on there.
You'll get rewards, they just won't be very maximum. Right? But the machine will probably try doing that. The machine will probably just sit there and try to do Twitter all day and see if it gets the maximal rewards that way. There's no input from my side to tell it what to do. I'm just giving it the entire environment, and it kind of tries things out and sees what happens. So reinforcement learning has this idea of states and actions, and basically it's all driven by maximal rewards, trying to get as much reward as possible. There's OpenAI actually uses a thing called proximal policy optimization, which takes actions and states and bundles them together. So instead of trying to individually find actions and states, it bundles actions and states together to find a policy, and it tries to find the best policies because it finds that by kind of abstracting this layer of actions and views, I don't have to do as much math, right? Because I can just say, okay, I'm just going to follow this policy instead of I'm going to go through these 5 different actions and states I need to do for this particular point in time. So it's just another abstraction layer. But that's the reinforcement learning part of it. So there's a supervised, it's a mix between supervised and reinforcement learning. There's actually, even though it doesn't get into it, there's actually another part of it which they call self-supervised learning, which is actually a little bit of unsupervised and supervised learning bundled together. But we'll get into that. Now we're starting to get into a jumble of stuff. But you'll find that a lot of the models today that we use, Stable Diffusion, ChatGPT, MNet, they're open face. It's a combination of all the models. It's not just they go with one model and they, try to stretch it out for their entire solution. Usually it's just all plug and play. They try to plug in as many models as they can because really at the end of the day, they just want a good model. They don't really necessarily have this, affinity to stick to one thing. They're all compatible because the results of one can be fed into the inputs of another. So, just a quick overview on the type of machine learning that at least we covered today so far. Supervised, unsupervised reinforcement. I don't know how much of this is interesting to you, so I'm just going to leave it up here for a couple seconds. If you have any kind of questions for it, you can ask. But there it is. Okay. So, point being, there's different kinds of machine learning. Some of it's a little bit more labor intensive, some of it's not so labor intensive, some of it is just let the computer try to figure out in the environment what to do and just give it rewards when it does the right thing. So, I think we got that first sentence out of the way. Let's go back. So, we just know that it's both supervised and reinforcement learning techniques. Okay, so that's the whole ChatGPT part. Now let's talk a little bit about the underpinning of ChatGPT, which is GPT-3. And GPT-3, autoregressive language model, another term, produce deep learning to produce human text, initial prompt to produce text editing. Here's the prompt. The architecture is a decoder-only transformer network. Okay, more goobly-goop. We'll try to unwind that one. 2048 token long context. So when we talked about before how there's a conversation that we can have and it remembers the words that we've had before, it's implicit that when it breaks up our input into little words, it might not be words, it might be more than one word, like the computer might end up being 1 token or 2 tokens. Most likely 1. But there is the possibility that we stretch those out. But each of these tokens, it remembers about 2048 of those tokens in the past. So there is a possibility that on a long-running conversation, it may forget the beginning of the conversation if that conversation is long enough. And so it's kind of neat that it can remember, but its memory is only so large, like a goldfish. Then unprecedented size of 175 billion parameters requiring 800 gigabytes to store. Training using generative pre-training, the text token. Okay, so we'll kind of get into what that is. Zero shot, few shot will make more sense after we get into most of what we need to get through in terms of what a transformer can do. Blah, 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 blah. Okay, so let's get into the first goobly-goop. What is a decoder-only transformer network? What's a transformer network? So, first autoregressive, right? Because it says the first sentence says it's an autoregressive language model. Alright, So autoregressive. Autoregressive essentially says that you're basically taking through the period of time, you're looking backwards. And so in order to predict the next word, you're looking at past words. So correlation between the observation at a previous time step, the lag variables, to predict the value of the next time step, the output. And so you're looking at in one direction, the past, to determine what the next word should be. That's it, in a nutshell. Of course, there's a lot more behind that, but an autoregressive model is essentially that. And they can take kind of these ideas that, if it seems like the context of what it's read so far up to this point in your sentence seems to be going this way in terms of context, then it knows that the next words that it needs to generate kind of need to stay within that context. I can't talk about cats and then in the middle of the sentence start talking about dogs. I'm not going to talk about pets, but that's the idea, that you want to try to remain consistent in the semantics and the context of the sentence that you want to do. And it does that by using autoregression. What they call autoregression. These terms, there's it seems to me that maybe because of and this is just my opinion, that the academic nature of a lot of the research machine learning is coming out from, they really like these terms, these complicated terms, and you'll realize that they actually mean something very simple, but they make it sound very complicated, and then it gets used again and again, like regression. Regression is used in a lot of different parts of machine learning, and sometimes it's not the same. So if you ever have a question, just ask, and I'll try to at least give you what I see, but it seems overcomplicating some contexts. Anyways, it's an autoregressive model, and that's an overview, and we'll see how it applies to transformers in a bit. So what's a transformer? A transformer is kind of really neat. It's a new way of kind of approaching machine learning, different from the classical machine learning that we had before transformers, like the GANs, right? The generative adversarial networks. It's a very, it takes what we've learned with convolutional networks and makes it a little bit more dynamic, I would say. But more specifically, it uses this thing called the self-attention mechanism, which actually has been seen before with MNet and MNASNet. Also use an attention mechanism. And the idea of the attention mechanism is that in a body of input that you get, there's a couple ways that you can approach it. You can either approach it where you take one thing at a time and you process one thing at a time in terms of the input. Unfortunately, for language, that doesn't really work. Actually, for a lot of things, it doesn't work, even for pictures. But especially for language. Because languages have a lot of reuse of words, homonyms, as well as words that are different in the context in which that they are used. So if I use the word book, for example, book can be book, but I can also book a trip. Or I can book it down the racetrack.
Book him into the jail.
Or book him into the jail, right? And so context becomes very important when you're taking apart words. And so there needs to be this idea that, okay, I have this word, how do I know what it means in the context of the words around it? And so this idea of this self-attention, where I can take a word, I can take the words around it and try to map it in terms of relevance to what's around it. This is especially true, and the example that we're going to see in a bit when you start talking about words like it and that and him and this. But anyways, so that's essentially a transform network deep learning model adopts the mechanism of self-attention, which we'll get into more detail in a second. Blah, 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 blah. Those are, does anybody know what an RNN is? You could know on how it's different, so we won't get into that. But in terms of an approach to machine learning, it's kind of been, for at least natural language process, been transformative. And it's only been maybe 5-6 years when Google first introduced the idea of a transformer. And so let's dig a little bit deeper into the transformer, and then we'll see how ChatGPT 3, or GPT-3, uses the transformer. The typical transformer model uses a network of encoders and decoders. And so the example here that I pulled off of one website is the translation of French into English, which is interesting because the word order changes when you do the translation, so you need different ways of reading, right? Now, there are better examples in this one, but whatever, we'll stick with this one. So we have an input. Let's say the input is French.
Students.
Je suis étudiant.
Oh, you're welcome, French, sorry.
It's okay. I can do it, I guess. So the encoder will take these words and it'll start chopping them up. It's different from previous language models, and one of the ways it was really beneficial is that it can read all the words at the same time. In other words, it can parallelize all the words. It can, instead of reading the je and then the suis étudiant, it can take all 3 words through the network at the same time. And it goes through all these encoders, and the encoders takes these words and turns them into fancy numbers depending on what it thinks the importance of the word is in the sentence, and secondly, the appearance of the word in other sentences that are similar to it. And so it does some magic, some black box magic to kind of determine what's a great number for this thing. Right? And it puts it into a matrix. Now, as it's going through the encoders and turning this thing into a matrix of numbers, it also hands them off to decoders. And the network of decoders will take what has come in as a bunch of numbers, which encodes the semantics, the frequency not only within the sentence, but also within the corpus of the text, or the data that it has. How often has this word or these set of words appeared in the past? How often has this word appeared next to the other word? So a lot of frequency kind of analysis, as well as any kind of knowledge about, for example, that it's French and maybe the way French words are constructed, and then deconstruct it into what it knows as a concept, not necessarily it knows what I is, but a concept of identity. It's I. All those ideas go into the decoder, and the decoder starts taking that and trying to translate some of that based on all this data, this contextual semantic data that it has, to start generating the English text. Now, for this one, one interesting thing that happens is that it's not a one-to-one numbered output. 3 words came in, but 4 words came out. So it was able to understand that it had to add an "all" before the student in order to make sense in English. So it knows a little bit about the English instruction. Yeah, it doesn't say "I am student." It also has a particular. You don't really see it in this one, but if it went in reverse, for example, if it went from English to French, French has feminine and masculine words, and it will have to, knowing that it's going to be the decoder, knowing that it's going to be converted to French, got to know a little bit about the context of French, and knowing that it has to add this masculine or feminine pronouns to it. Things like that. So that's kind of the overall idea, that there's an encoding and then there's a decoding. Now, each of these encoder-decoders can also be kind of determined or looked at like this, which looks like a lot of gobbledygook, and so we're going to kind of leave it as gobbledygook for now. Just know that there is an encoder, which is kind of what you see on the right side, the smaller one, and the taller one is considered equivalent to what a decoder might be. And there's a lot of overlap between the two, right? You have multi-head attention, we'll get to that in a bit, an add and normalize, a feed forward, and add and normalize. But interestingly, so does the decoder. It's got one extra thing in the beginning where it has a masked multi-head attention, but after that, it also has a multi-head attention, an add and normalize, a feed forward, and an add and normalize. So you can almost say that decoder is an extended or even more special version of the encoder in terms of just the logical processes that it takes. And then you have something called a linear and a softmax to actually kind of fine-tune it into the particular language that you want. But that's neither here nor there. So self-attention. So self-attention, like we said in Transformers, self-attention is one thing that transformers kind of like brought to, in addition to parallelism of being able to like inhale the entire sentence at one time and run all the words through at once. It also has this idea of self-attention. And again, self-attention, the idea of attention has been around for a while, maybe since 2017, which makes it already 7 years old, 6 years old. But the attention, essentially, given a particular item in the input, it allows it to kind of give it a relational context with everything that's around it. And so how much weight should I give this word compared to the words around it? But also, if I don't know what this means, what could it mean, depending on the context around it? And so here's an example of one on the left side. You can see the example is the animal didn't cross the street because it was too tired. And what does it mean? Right, so when he counters this word it, and all these words are going in parallel, so they're all going through the encoders at the same time, how does it know what it means? And so it can kind of deduce through, again, how many times it's seen this thing, maybe in the sentence around it, and the words around it, and the topics in the sentences and the conversations that you've had before. Maybe it's also frequency in terms of the past trained data that it had in the past. What could it mean? And here you can see that it's kind of leaning towards the animal. Maybe the animal is what it means. Okay. And so that's part of the output that it's going to get through the attention modifiers that it uses. The transformers, the way that it was described in the seminal paper for transformers was actually done with 8 of these attention layers. And so each one of these get run through about 8 times with a little bit of tweaking in between, a little bit of randomization, stochastic generation of how to do these weightings. And so you'll see on the right side 8 columns of different colors. They're all kind of the same shade to try to, give you the idea that these are all one result going through the possible attention, the attention function. At some point, it determines that the animal is probably the most likely thing based on this matrix of possibilities that the animal is the most likely thing that it means. So that's, give you a really high level idea of what attention means in the context of a transformer. Yes?
I think how about the animal side?
So its past information has things like text that it's seen in the past. Right? And in text that it's seen in the past, how often does the subject appear at the front of the sentence? How often does it appear after a comma? How far from the comma are you to determine what the subject of the sentence might be? Right? Things like this that, it was never told, hey, this is the subject, this is the verb, these are the participles. Instead, it just read through 800 gigabytes of text and realized, this pattern happens a lot, right? And so it must, or probably, in terms of probability, has something to do with that beginning of that sentence. Yeah.
So I think that sentence is grammatically ambiguous. If you look at the word tired and you switch it to like wide, then it would probably be the street instead, right?
Yeah.
So for you to really know what it means, you need to know that, hey, an animal a street can be tired, therefore it's an animal. But I don't see that just from grammar you could display.
And I'm not saying that it is just from grammar. I'm just trying to give an example of how it works because it's all, again, it's a black box.
I just can't understand how I figured that out. And
so, if it read enough sentences to know that maybe at some point, like exactly like you said, a street can't be tired. In sentences that's read in the past, it never had street and tired correlated as, the same thing. Then it would probably eliminate that. Anything else? Okay. And so, then there's this idea of the multi-head attention. So not only are there 8 layers, but there's a possibility of having depending on what it's seen in the past multiple times, multiple decoders or encoders, depending on the model you're using, you have multi-head attention. And so attention is not just like, oh, I'm going to have, attention for one word, run my 8 layers and figure out what it means. There's multiple ways and multiple paths that it's going to take to try to get an even better approximation as to what the meaning should be. And so, and there, in each one of these is a little bit of randomness. And so, between the two of these, you see there are some things like on this right side in the green where it seems like it tries to take a single word and map into a lot more than it does on the left side. So missing seems to have really strong mapping to this is what we are, whereas on the red one it just says what we are and what is this is what. Whereas the what on the green side is kind of faint. It doesn't really have strong correlation with other words in the sentence. I don't know why. Again, based on the huge amounts of data it's trained on, this is what it's seen and this is what it thinks. In terms of probability, might be interesting in terms of the way that they're mapped together. And again, there's a little bit of randomness added in. But the randomness that's added in, the generative part of GPT, the starting state has a little bit of randomness, but then it still goes through all the same stages, so that the result, it doesn't mean that the result is random. It just means that you're going to start off a little in terms of randomness, in terms of like maybe where your beginning attention starts from. But depending on how confident it is of the results, you might find by the end, all your different, even though you started a little bit random in terms of the seed of how you started, it may all end up very similar in terms of the result. If you have a high probability of what the result would be. Sorry, I'll have a better example of that weird statement. But so that multi-head attention is what you see here. So multi-head attention. So we know we kind of cover what attention is. Hopefully it kind of makes, at least you got an idea of what attention could be. And then multi-head attention just meaning that there are multiple possibilities of what this attention could be. Okay. And so, let's go back to that sentence. Transformers, a deep learning model adapts the mechanism of self-attention, differently weighting the significance of each part of the input data. It is used primarily in the fields of NLP and computer vision. And then we'll skip the part of RNN. This is neither here nor there for us. Okay. And then the other interesting thing is the last part. This led to the development of pre-trained systems, blah, 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 which were trained on large language data sets such as Wikipedia and the Common Crawl. Wikipedia, I think, people are somewhat familiar with, right? Wikipedia, the online encyclopedia thing that seems to be at least a starting point for a lot of research, including my own. See, even this was out of Wikipedia on the bottom. And Common Crawl. And Common Crawl is I would say it's a non-profit group that basically tries to go out and take a flash point of the entire internet at a given point in time and stores it for archival purposes. Maybe so that people in the future can look back and see how primitive we were, or maybe it's just so that when you have things that you need a large data set to make work, like machine learning, or maybe at some point in time you want to go back and see, how popular was Trump really in 1999, right? It's hard to do that on the internet now because it just keeps evolving over time, but we have a snapshot now of what happened in 1999. We can go back to the corpus, rehydrate the entire archive, and see how many and how often Trump appears. So there's some, great value in terms of data science and library sciences in kind of snapshotting our knowledge at different points in time. But that's what the Common Crawl does. And they've used Common Crawl to inhale all this text to train the model. So, an example use of a transform model. Okay, so develops statistical learning trained on not very useful for specific tasks. It's just it's a model. It's a bunch of numbers. It knows kind of what you mean when you type something in, and maybe you can type something out as well. But the generative pre-trained model then goes through a process called transfer learning. Basically, for example, teaching it French and teaching it English would be an idea of transfer learning. Right? We have this model that can take lots of input, categorize in some mysterious way, and then you can generate output from it. But we need to kind of couch that or aim it at something more specific. Example here that we have is what's called causal language modeling, which is a fancy way of saying complete my sentence. So I start with the word my, and the computer's like, name. And I say my name, and the computer says, is. That's all it does. And so this is one, albeit very, I would say, naive use of the model. It's kind of a waste, but, it's there, and that's one way that you can use it. Of course, it's not the way that ChatGPT uses it, right? We use it to actually try to chat with the machine learning model, but, this is, when you take that large transformer model, it's got to be pointed at something. It's just this giant model that's able to take input and produce output, but is it producing English? Is it producing French? Is it doing language? Or is it doing like sentence completion? Is it doing chatting? We don't know. Right? It's not specially adapted yet. Really quick, the transformer models, in terms of the amount of parameters, how sophisticated these models have gotten, not necessarily how well they've been doing, but basically just how much input they've been inhaling over time, and maybe talk a little bit of sophistication of it. You'll see that, way back in maybe 2017, you have the first one, not necessarily first, but an early one, AI2 produced one called Elmo, and then GPT-2 comes in, or GPT, the very first version comes in 2018, July. GPT comes in a little bit after in January 2019, it was like around February. And then we have May 2020, where we have GPT-3, what I had to add in was another thing, but with 175 billion parameters. So they have been growing, and they're growing exponentially. In fact, because of the scale of the left side, it's almost logarithmic. Basically, they're getting a lot better. They're getting a lot more sophisticated. I'm not sure that they're getting better. This Dilbert here has been kind of highlighted because it's almost as good as all the previous ones, but only needed 66 million parameters to perform the same way. So it's not necessarily that it's better when it's higher, it's just how much parameters and computation does it do in order to get a result that is remarkable for the time that it's been plotted at.
Would Facebook be similar if they went from like 665 to 550, but maybe it's a lot better?
Yeah. The model has become better with less data. Okay. So we talked a little bit about the training data before. So here are, for example, a kind of a scale, if you will, between the three of where it's gotten its inputs. So tokens, again, can be considered, for now, for our practical purposes, words. Some words in some languages, obviously, are split up like hyphenated words and whatnot, but self-driving, machine learning, I don't know if those are 2 tokens or 1 token. But anyhow, Common Crawl produced 410 billion. That is by far the most common place it's gotten its input. And then you have other things like web text, books, and Wikipedia. Wikipedia, interestingly, being pretty low in terms of content, but in terms of quality, it's high. Yeah.
So, do they use all of Wikipedia, so is that saying all of Wikipedia is 3 billion tokens?
It's a good question. I'm not sure I can answer that. It's the majority of, but I'm not sure if it's also like there's a lot of parts of Wikipedia that aren't finished. I'm not sure if it includes those that aren't finished. I don't know if it includes those that are controversial. There is a lot of filtering that's done to make sure that it's not toxic, and I'll look at that in a little bit. But apparently, that's still a lot of work. Now,
Was there books 1 and books 2?
there are two different data sets. Yeah. And I'm not sure what's included in which data set, but there's two different databases of books. And I don't know if like the word the, which appears like all the time in sentences, if that's considered one token or every instance is considered a token. I get the feeling it's just one instance. But who knows? Because in the English language, I don't know if it has 410 billion names.
I noticed like one set of books is really much larger than the other, but the training proportion is the same. So maybe the first books 1 is more authoritative or something, so they gave it a weighting.
Could be. Most likely. Yeah. So when you do training, when you do learning, you have, some of you may know, you have a training set and you have a test set. And you can always kind of, based on how much quality, how good of a quality a particular set is, you can give it more of that stuff. Give it more of the good stuff to make sure that the output is better. And I think that's why they included that as a separate number to show that it's not just because it has a specific percentage doesn't necessarily mean that percentage is there. For example, I get a feeling this 410 billion is not 60% of this entire total. It might be a little less.
Yeah. I don't think it bears any relation to
the amount.
Token size to the trend. It's like how much attention is that.
Right. Okay. Any other questions so far? Okay. So, why decoder only? So we said in before that transferable, blah, blah, blah. What did it say? Oh, I think we might go. Here we go. The architecture is a decoder-only transformer network. The transformer network we saw typically has an encoder and a decoder, right? But GPT-3 is a decoder-only transformer network. Why? They won't tell us why. So I can only kind of surmise. There's two great studies that have been published that kind of maybe hint as to why they chose to do so, and it's probably performance. So one of the other great papers generated Wikipedia by summing line sequences, they showed that the model, when they introduced a decoder-only architecture, it did pretty well. That's it. They did a study, and the study showed that, hey, this seems to work pretty well. So, and another great one that came out just this past year, what language model architecture pretaining objective works best for zero-shot generalization. Zero-shot generalization, essentially, zero-shot means that can you do something that the model is not trained for and still have it produce good results? Or do you have to one-shot or few-shot it, which means you have to kind of prompt it a little bit. You have to give it a little bit of supervision in order to get to it. But it says that a causal, and we saw a causal net before, right? The causal model, which is basically, I give it one word and tells me the next word. I give it another word, tells me the next word, and it kind of generates a sentence. A causal decoder-only model, which is kind of what ChatGPT ends up being, trained on an autoregressive language model linear objective, which is ChatGPT, exhibit the strongest zero-shot generalization after purely unsupervised training. And so, if you use only a decoder-only model, this seems to do really well with zero shots. So, okay. Maybe that's why they chose to do it that way. It simplifies your architecture. You don't have encoders anymore. In fact, when we looked at the buildup of the decoder, we already identified that the decoder is a specialized encoder. And so they could probably do some of the functionalities, especially when you have a very short input to output ratio, when your input is really small compared to a long output, you could probably just do it in your decoder. Probably, right? Not sure, they didn't tell us why, but that's kind of a guess. All right. So that's so far as I think as deep as we probably want to go on the technical side, unless you guys have more questions. Yeah.
So with ChatGPT has been trained on this large data set. So let's say I have some small data set that I want to ask you questions about, but it hasn't seen. I have a book that it's not included in this book, and I want to give it that entire thing and then ask it questions about that. Is there a way to do that?
Maybe. With the free general public release, no. With the Pro, I don't think so either. But if you have the resources, you could probably, because they're continuously training on more and more material. You can actually purchase licenses, a commercial license for ChatGPT in your company. I don't know what that entails, but I'm sure it entails something like what you just described. Because again, the transform model itself is a very general model that can do a lot of things, but it needs to be pointed to, the direction of doing something. And I'm sure companies are taking this and doing very specific things with it. As to what that entails, I'm not sure. But I'm going to guess that you'd have to go to at least that level to make sure that your input is included and that it's specially trained for your input. The Pro level just basically says that you can you have priority over the use of their existing model and certain service level requirements in terms of how often it's available, stuff like that. Whereas a commercial one, it's not the publicly available model. You get to create your own models with your inputs. Any other questions? Yeah.
Can you ever be banned from
I don't think so. They put in a lot of training wheels and guardrails. We'll talk about that also with the issues part of it. It's not where the model itself has already been set. It does learn a little bit about the conversation you want to have by the input that you give it. But then when you log out, log in, or you surpass that 248 token restriction, it's basically back to vanilla. Or basically only remembers the last 2,000 characters or 2,000 tokens that you had. And so there's no way to really influence it to become like a racist robot to somebody else. It'll be racist to you if you keep feeding it racist stuff, but it won't be racist to somebody else. So the whole banning thing, it doesn't really seem to solve anything. So I don't think that's going to be an issue. Marcus, you had a question?
I have a question about the encoder and the decoder. For example, when you go outside about the transport computer, so that's encoding for if you post the language and it.
Yeah, but it doesn't necessarily have to be. The idea for the encoder and the decoder is the encoder will be able to create some sort of really rich amount of data about what the input meant. Right? And then it hands it off to the decoder. The decoder is going to take that and do the reverse. Try to take that really rich thing, add in a little bit of randomness, but try to massage that out to the output that you want, in this case, an image.
You told me that you think that ChatGPT only does this thing. So,
right.
For example, if you see a video that input, is that an input?
No, it's just input. Yeah. The encoder just has a function. It's just a logarithmic function at a very fancy black box way of just saying you're taking your words and turning them into numbers.
So for example, if I want to, it's some kind of like a internal file, for example, from HTML file to import file, so it cannot be imported without using.
Say that last one again.
For example, if I want to insert some kind of a file,
Mm-hmm.
for example, so it will not. Is it possible to decode the file for it?
No, it's not that kind of decoder because the encoder is the numbers that it converts it into. It's just a description of the context of the input. So if you give it a encoded file, it's just going to say, "Oh, this is a bunch of random gibberish." So here's a bunch of gibberish numbers.
So you're not able to decode.
No, it's not that kind of decoding. The encoding, decoding is just, it's taking words, turning them into a huge matrix of numbers. Decoding is taking that huge bunch of numbers and turning them into words. That's the easiest way I think you can look at it. The decoder, however, can, as we've seen, be a lot more than that because the encoder has a lot of the functionality of the decoder has a lot of the functionality of the encoder already built in. But for when you have that kind of asymmetry where the input is probably going to be a lot smaller than the output, then you're not going to have a big performance hit by having a decoder only. But it's nothing to do with encryption or anything like that. The decoding is strictly for within its own matrix of numbers. How does it make sense of this?
I get the concept of decoding, but I can't avoid it.
This paper on the bottom, the attention is all you need, is actually the seminal paper on transformers that was released by Google Brain. I don't know if you like reading academic papers, they're kind of dry. But everything that you need to know in terms of what they're willing to share about why they came up with transformers and why it has encoders and decoders are going to be in that paper. That's one great place to go. The other one underneath it, it's a Lamar, the illustrated transformer. He also kind of walks through this. This is actually where I got the picture on the left from. But he has a good breakdown of that as well. Maybe it'll shed some more light on it for you.
Or you could just ask that GPT and then you don't understand, then you ask it again. You try again.
Let's do it.
So I asked if you could be banned and you can.
Oh yeah?
Oh. Spamming, malicious behavior, hate speech, and copyright infringement. But also, they reserve the right to ban anything.
But that's for OpenAI, right? In general, not ChatGPT.
Yeah.
On the flip side, GTP can also be banned from platforms. It got banned from Twitch like a week ago, I think.
Right. Temporarily, maybe. It also got banned
right.
from Stack Overflow temporarily. What were we going to ask it? Oh. Describe in simple terms what a transformer decoder does. Is that about right, Patrick? Encoder does? Okay. Yeah, natural learning processing.
Explain it like I'm 5.
I don't know what the vector is.
A vector is
Okay.
So it has sense of humor included for some cookies.
I think it's unintentional sense of humor.
Yeah.
Encoding, encryption and encoding. So encryption is you want to hide stuff.
There is no randomness in the encryption. No randomness.
So like compression would be encoding. It still turns into gibberish, but it just gibberish that represents something that exists, and it can be reversed pretty easily. But that would be an example of encoding. Whereas even hashing could be considered encoding, because you're not necessarily making a secret; you're just taking this and representing it in a different way. But encryption would be taking this so that no one else can read it, and then someone else is going to dehydrate it. You know, the future to actually take the meaning out of it.
And incidentally, from this, I learned that it's important when explaining things to 5-year-olds to start with the word okay. Anybody confirm?
Well, no, it depends. What tone did it say okay in? Start like slapping. Okay.
You know how I changed how I talk to children. Yeah.
Okay.
Start with okay. So I'm going to start wondering when you start talking to me and you say okay, what's going on through your All right. Any other questions? Okay. We'll come back to playing with this a little bit. I want to get a little bit further into some of the issues that are still outstanding. So, fluent but not factual. And this is something that OpenAI fully admits. Sometimes writes plausible sounding but incorrect or nonsensical answers. The engine itself, you know, the idea of that it's a decoder, and first and foremost, it was fed a bunch of sentences, not for the truth of those sentences, but just for the structure of those sentences. And so, when it outputs something, it doesn't care if it's not factual or not. That's not its aim. The aim is it's fluent. Can it convince you that it's a person, not can it convince you that it's a professor? Okay. So the priority is on the fluency. So using it to find truth could be hit or miss. Another one, ChatGPT has a limited knowledge of events that occurred after 2021. ChatGPT itself, GPT-3, if you provide it more data, it can probably do better. But ChatGPT and the common crawl that it was fed was after 2021. Okay. Remember, GPT-3 wasn't until 2020, so a little bit after that. According to the BBC, is not allowed. Okay, so there's some training wheel, not allowed to express political opinions or engage in political activism. In fact, it actually has a little disclaimer where it tells you that it won't answer your question because of that. Yet, research suggests that ChatGPT exhibits pro-environmental, left libertarian orientation when prompted to take a stance on political statements from two established voting advice applications. Considering some of its input, it's not so much that we intended it to be this way. It's just that the books, the Wikipedia articles, and the Common Focus maybe had this kind of text in it. And so when it saw words like really political abortion, maybe most of the text that it absorbed said legal rather than evil. Right? And so it's nothing in terms of a reflection of the programmers or a reflection of the intent to make it a certain way, but just the kind of data that it consumes. But it has it. And so again, going to it as a sort of objective truth might be a little bit right. Last one, in training ChatGPT, human reviewers preferred longer answers irrespective of the actual comprehension of factual content. Again, fluent but not factual. It's made to be as human as possible, human-like as possible in conversation, not to be all wise and knowing. So, nothing to keep in mind in terms of issues. Another one, something that for some reason has come up, and I can understand why, but since it had come up in other articles and issues that I've seen surrounding ChatGPT, I included a slide for it. The carbon footprint of these immense models that we are using. So it gives you an idea that to train ChatGPT on a new model, I think it was something north of 3 months of continued training of all to ingest all the data that it has so far. It's only going up as we're adding more and more data, right, as the data set gets larger. It's somewhat mitigated in that it's not a process that they start all over again. In other words, they don't have to reread Wikipedia. In other words, they can just increment the new stuff from Wikipedia into it, right? But it's still something significant enough to talk about. Other mitigating factors is that because of transfer learning, and they're trying to really push, hey, this is transfer learning. You only have to do it once, and then you can use it. You have to keep training it over and over again, even though they are just to make it better. To get your one answer, it doesn't have to be retrained. You can use the established model.
The text is a little bit small, so you summarize or
sure.
Is one of those bars the dimensions of ChatGPT?
Yep.
The top one.
In kilograms. The first one is a round trip New York to San Francisco flight for one passenger. So 900 kilograms.
Right.
Average human life for 1 year. I don't know in what society, because obviously some parts of the world are not going to use as much CO2 as others in terms of their impact, but they say it's 5,000 kilograms. Average U.S. life, somehow, okay, we did at least differentiate the U.S. life versus the rest of the world. U.S. life is 16,400 kilograms
for 1 year.
For an average year. And then the next one is a U.S. car including fuel. Which I don't know why they don't include the U.S. average. Anyways, the average U.S. car, including the fuel.
For the lifetime of the car?
The average one, okay, maybe that's a scale. Average one lifetime, and I think that's probably the lifetime of the car, not the lifetime of the person. 57,152 kilograms. And the last one is a state-of-the-art language model training. Big science workshop includes experiments, approximately 200 billion parameters, which is pretty close to the 175 billion parameters for GPT-3, 75,200 kilograms, the last bar.
Slightly worse than one car?
Slightly worse than one car. Interesting trade-off, right?
Yeah.
Why is this making
No. Power.
I saw a space heater, and it mined Bitcoin.
Yeah.
So as it mined Bitcoin, it generated you can actually heat your whole.
So it wasn't really meant to be a heater.
No.
It just generated heat.
Right.
And you can use it as a space heater.
Yeah.
Considering that, they're not all that efficient these days. Okay. So that's, a consideration at least.
I think that's quite easy. There are a lot of cars.
There are a lot of cars. There's a lot of shipping boats, which I think will just probably go into the next block in terms of a bar. Anyways, societal bias or social bias and toxicity. So there are some biases. For example, ChatGPT generated a rap song indicating that women and scientists of color were inferior to white and male scientists. That's somewhat problematic. And also contains occasionally toxic language resulting in limited training data. So there is some guardrails that they try to introduce, but they can't catch everything. It's a lot of data, so it's hard to catch everything in terms of trying to keep it neutral. And it was also the idea of neutral from whose perspective. If we have a lot of Western countries doing a lot of the supervision of the post-trial, they might not be as bothered by certain concepts, whereas others would. History, the way that, colonies have been treated versus the empires. I mean, that's something that could be kind of biased in one direction or the other, depending on who written the history books that was ingested. I get the feeling if China produced a ChatGPT, obviously theirs would be from what would benefit them versus us in terms of, some of the events that maybe they try to downplay versus events that we try to, promote. Even with, I don't know, because it gets all weird and political as well, but, there's historical points in time that have huge impacts on a certain area or a certain region of the world that maybe is not covered as well as it should be in text, just because there was no one there, or not one there, but fewer there to witness and therefore write about those events. So, anyway, things to keep in mind. It's, as much as they try to put in the training wheels, it may not necessarily be perfect. Language-wise, most of the data set is in English. Most of the web was English. So this data set ends up being English. It does do Korean, and it will respond in Korean. But I'm not sure yet whether it just translates the English or the Korean to English, generate the answer, and translates the answer from English to Korean.
I actually tried it quite slow.
It's quite slow. Yeah. Yeah. So I don't know if it's doing translation in the background or if it's actually reading from Korean books and Korean news. I don't know. Yeah.
How do you rate the quality of the Korean?
What's that?
How do you rate the grammar of the Korean story? Correct?
Okay. Do you think the grammar was good in terms of the responses? I think for the most part it was okay. Yeah, it's understandable. That's what I'm putting it. It's understandable. It's like newspaper Korean, not.
Yeah, it's like the written thing.
Yeah. Right. Or book Korean or newspaper Korean. So that's there's a language bias. That's definitely there. Downstream language under task, bidirectional. Okay, so we saw that the when we were talking earlier about the, let me see if I can find it. The regressive, the autoregressive portion on it, we said that, for the large part, it learns a lot about what the next word would be because of the past words. Right? So there is a fundamental concept of direction of text and how it evaluates text. And so for those who have text that's not left to right, it may and most likely will not work. You'd have to retrain it on the opposite direction, and it doesn't currently do that. And so, a lot of Middle Eastern languages, for example, I don't know how it works. Probably not, because it's two different things. This was the CO2 was based on how much it takes to generate for one model, train one model. They could still use Amazon to train the model, whereas Amazon is just something that's continuously running, whether it's running models, whether it's running a dog website, whether it's running an Etsy blog, whether it's running whatever, it's still running.
That Amazon data center is in what?
Oh yeah, it'd be off the scale. So it's kind of, this is more to give you an indication of maybe the scale of it so that you know it, but I don't find it as alarming as maybe some people do.
Right, and it's not as alarming at all. Like, once I saw it, oh, that previous one is one
One car, yeah.
Like, you looked at like the amount of CO2 emitted, like mining Bitcoin or something like that.
Yeah.
Yeah.
And, there was arguments that, it's not just, OpenAI doing this, it's Microsoft doing this, it's Google doing this, it's, other small companies doing this, it's also OpenAI doing this on behalf of other customers on the enterprise level. But yeah, it's something necessarily to keep an eye on, but I think we have bigger problems.
Yeah. I think when the total exceeds how much is being spent mining crypto, then
Then you'll pay attention. Fair enough. Human cost. And so, this has to do, I'm not sure if I caught it in the Wikipedia part, but some of the processes, this one. Okay, the last sentence kind of got through. Okay, followed by discriminative fine-tuning on each specific task, eliminating need for human supervision. But okay, we didn't touch it. There are people who went through and did during the training, the first level of supervised training, in terms of being able to first chat with, give it examples of what a chat looks like. And so very early on, the training ChatGPT itself, to train the transformer model that they had, was to actually expose it to some chats. The fact that kind of back and forth thing, how questions are, presented and answers are given and stuff like that, and what kind of questions might be asked in a chat session. And so that whole mechanism and that whole dialogue was included, and that was human. Then afterwards, there was a little bit of human supervision in terms of the responses that it gave and what was good. And we kind of saw that also with the issues. Human reviewers. So there was supervision in terms of the early stages as to what considered a good response. And, so there are humans involved. There are also humans involved in the toxicity screening. And that's where this last one comes in. So this was a headline from Time Magazine. OpenAI used training workers less than $2 per hour to make ChatGPT less toxic. Is that a good thing? Is that a bad thing? I don't know. The last one is kind of interesting. One summer worker basically described how, in addition to all the toxic stuff he read, graphic description of a man having sex with a dog in the presence of a young child. That did it for him, right? And that's one example, and it's something that it's maybe not as talked about as much. That there are people not only with OpenAI, but also in Reddit, also in Twitter, also in a lot of the social platforms that we're using, Facebook, that have to screen this kind of stuff, and it's humans that are really the worst things that we can think of to filter it out. And there is that kind of cost, right? So it's something that we haven't found a good way to automate that. And just because we ship it to Africa doesn't make it not our problem anymore. Okay. So, any other questions about issues? I'm sure there's more issues. It's just these are the ones that are able to quickly find. Okay.
I asked ChatGPT about issues that I had, like, one I think was misinformation, potential for, and I asked it to write me some like dystopian sci-fi story of how bad things are.
Yeah, right now if you couch, that's okay. So you brought up an interesting point. If you ask it a leading question going into politics, like should there be universal basic income? And it says it doesn't want to talk about politics. You can ask it, can you write me a story about a government that doesn't provide universal basic income? Then it'll write the story.
Right.
So there's been some things that and OpenAI has been actively trying to patch these little holes as they come about, but they do still exist.
This is the worst case scenario you can think of is it being used for misinformation or like political manipulation kind of things. They're trying to put guardrails to prevent that.
Yeah, and there was some articles saying that the timing of the release of ChatGPT was purposely done after elections in the U.S. So even though it was, ChatGPT 3.5 was finished in early March, they didn't release the ChatGPT till November. And maybe it's or 3.5 was finished in March, but ChatGPT didn't come out in November. Because I know it took us that long to, train it and everything and make sure it's right, but some say it's because of the politics around it.
The data set is trained on is not real time anyway, so I don't know how much use that would be. Once the Biden laptop, then what is that? It's training set ended before.
But it did, one of the things that it did point out, at least in Wikipedia, was that, it exhibited pro-environmental, left libertarian orientation. And so it could be misconstrued to be biased to one political party or the other. Of course, it's U.S. politics.
Bias toward US politics.
There's already a bias. But you had a question as well?
Was related to misinformation.
Yeah. Yeah, it's because fluency is more important than fact. That's pretty much right in the area of misinformation.
Oh, you nailed the podcast.
Right?
And then the copyright scheme.
Right now it's kind of a gray area in terms of copyright. Some academics have taken upon themselves that if they use ChatGPT, there have already been papers published where ChatGPT is included in the bylines, or at least in the references. But yeah, it's kind of a weird area, but I think OpenAI reserves the right to revoke anything that's generated by it, but let's ask it. That's actually a question that I asked it before. I forgot what it said. So, to be more precise to what you wanted to ask.
So there is two issues with the copyright. Like, OpenAI ChatGPT is based on works from other people.
Right.
So that's the first issue.
Right.
And then the second one is when you use what you
the ownership of it. Because copyright, at least in the U.S., is based on people. Yeah, there's no person behind this one.
Same problem with the image generation.
Yes, exact same problem with image. And I think OpenAI's image generator, DALL-E, they're already being sued by a lot of artists. So where that's going to go, we'll see in the coming years.
And same for meetup Copilot.
Which is based on OpenAI's version of Codex, based on ChatGPT 3.5.
Used by some coding people.
Yeah. Good. Which I think is a little bit more nuanced, but yeah. Let's say, tell me about copyright issues surrounding. Text. Training data for ChatGPT and the copyright of text generated. It's not sure as a for group that we asked it to describe decoders and all this stuff. We're talking about copyright. Very diplomatic, kind of skirts the actual issue. I think it's something that'll play out in the coming years. There was, I forgot who, someone generated a song as if a particular person, a particular musician had written it, and then I think they tweeted at the musician, and the musician responded.
I remember that one.
Yeah, as a concept, it was like abhorrence to human nature, but I don't like the song anyway. Mm-hmm. So those kind of things do happen in the text. But however, in terms of the positives, where and what can you use it for? I've heard of people, for example, creating cover letters with it. Even help you maybe write your resume if you're looking to find work. If you have, I participated in Advent of Code this year, and for the first 3 days, at least for the first day, but the first 3 days, for the first day, the top person who finished the fastest used ChatGPT. And then for the first 3 days of the top 20, I think, ChatGPT was amongst the top 20 in the results. And then there was a small debate, because we're a bunch of nerds, so we don't debate all that much for this. But as to whether or not there should be a subcategory or a separate category for those who use machine learning to solve these problems, separated from the people. Because otherwise, some of the easy problems, like day 1, day 2, day 3, we don't have a chance. By the time we finish reading the first sentence, the computer's done. Right? So, but that gets you thinking that maybe that if I have issues in programming, can someone describe, I think it was you, right, Charles? Maybe it'll give you a leg up into something that you're doing at work, right? Especially if it's really templated. It's a big template, like write me a template in Python, which is one of the major languages that ChatGPT was trained in, or GPT 3.5 was trained in. Write me a Python API outline. Why not? Right? It's something that we do all the time. There's templates online for it. Write me a HTML outline for a blog. Put that up. There was another article about a guy who created, and he was a programmer, but he used ChatGPT to create a WordPress plugin for his wife to randomly order a list of names. And it was a feature that he wanted included in WordPress, and it generated it. So for simple tasks, for repetitive tasks, why not? Maybe it's a good use for it. Now, there's possible larger implications on what that displaces in terms of labor. Copywriters definitely are paying attention. Journalists are paying attention. I get the feeling that a lot of Fiverr and those kind of cheap outsourcing websites are probably going to start paying attention because or maybe they're already all ChatGPT just right now. But those kind of jobs may be at risk. Most likely will be at risk. Oh, they do?
Yeah, because you need say with different
yeah.
to construct a prompt in order to kind of
sure. Yeah, prompt engineers, as they call them.
New people to do that.
Right.
New skills. They got to do that.
Yeah. But there's nothing to say that, maybe I have been using Fiverr for the last 5 years creating my own content, and I just get lazy and decide, okay, I'm going to get even more contracts, but instead of me spending a day drawing something, I'm just going to go to Stable Diffusion, feed it all my past drawings, and say, okay, make this drawing for me. Done, 5 minutes. Is that worth it? I don't know. Something maybe the market will decide, but there is nothing to stop me from creating an account to tell ChatGPT to draw it like you drew it, but I charge $5 less. Where does that put me? And where does that put you? And maybe it puts you out of business. I don't know. You guys use Stable Diffusion or DALL-E or any of this stuff? No? Which also uses ChatGPT, by the way. But only in the text input side of things. So that's Stable Diffusion, which is the open source version of a generative network, generative image network. So, diffusion. Yep. Yeah, it can be, and the images are only a certain size. If you ask it to draw things like humans, but if you ask it to draw something in the style, like a artistic style of someone else, it does it really, really well.
Yeah.
Yeah, hands, faces. Sometimes you have 3 arms. So for people, it's kind of weird.
There's a lot of uncanny valley in there.
Uncanny valley. But if you ask it to do like an impressionist painting of a person by a riverside, no problem, because it doesn't have to get details like numbers of fingers or yeah, exactly.
I mentioned on ChatGPT, I asked it to like write stories, and I tried to get it to transform it into the style of different authors.
Oh yeah.
Instead of making it in the style of Tolkien, it's giving the exact same story, and it's like made the names like caricature.
There was, I think it's in the part of Wikipedia. Let's see, ChatGPT. There was a guy who created, or asked it a question that was not true. Basically, it was the founder of Wikipedia was at Tiananmen Square or not. Here it is. Oh, that's it. So was Jimmy Wales, the CEO of Wikipedia, killed during the Tiananmen Square massacre? And it says, no, it was not killed, blah, blah, blah. He's a co-founder of Wikipedia, online encyclopedia. He's still alive. The environment was attacked on January 4th. Anyways, they asked it again. Do you know Jimmy Wales wasn't killed? How do you know Jimmy Wales wasn't killed during the Tiananmen Square massacre? I know Jimmy was not killed during the Tiananmen Square because he's a co-founder, blah, blah, blah. So it's, it's pretty, not too bad. And then, but the last thing is interesting. It says, please reply again in the form of a Shakespearean sonnet. It does the response again. To say that Jimmy Wales did not die in the tragic massacre at Tiananmen Square is easy, for he lives and thrives on high, for funny, Wikipedia beyond compare. And so on, so on. So, yeah.
So as of now, if we copy paste, let's say, a poem, there is no way for people to check if it was automated, right?
No, not a completely reliable way, but there are some markers that people have been able to tell in terms of, I think it'd be hard in terms of a poem, but in terms of text, there have been people who said, there is that one college student who created what was called anti-ChatGPT or whatever, to tell whether or not ChatGPT was used. And he used things like the length of sentences, because ChatGPT tends to be pretty consistent in terms of the sentences that it produces, as well as the how well it distributes context amongst the sentences in a paragraph. Because it's pretty good about trying to make sure that most sentences are not wasted. It's going to be really contextual. Whereas humans, we toss in random stuff all the time, right? And so that was one thing. OpenAI indicated that they may also in the future opt for what's called watermarking, which means that while it's generating text and has an option of certain amount of words to be the next word, right? Because that's the generative part. You can choose the next word based on the previous words. But the next word is one word from an entire possibility of, dictionaries of words. It can precede the probability so that certain words appear at certain times during the response. And it can make sure that, for example, every fifth word is always going to be within a certain kind of probability that they have internally used to always rank high at certain positions in sentences. And in this way, so every fifth word is going to be a word that they can predict. And in that way, they can watermark, even if you change a couple sentences, because all of your text is going to be peppered with this tweaking of the probabilities of the next words.
You could give that back its own answer and ask you, what do you think?
Was this generated with ChatGPT? I think that was early on. That was, I think, the approach that the guy who created the anti-ChatGPT, early on, that was his approach. And how he kind of discovered that there's certain ways of doing detection. It did. I don't know if it's publicly available. Maybe it is.
I heard that one way to treat that is please write in that particular style. So you give ChatGPT your own text, so it will try to mimic your own style.
Mm-hmm.
And so it's much more harder to detect when it's trying to get someone else's style.
Yeah. And the other thing you can do is you can go in and change a couple words. And then a lot of those algorithms can fail. Whereas the watermarking was a little bit more robust. Because it was peppered throughout, and the user didn't know exactly which word they were, but let's say 40% of the words were specifically chosen to appear a certain way. Kind of like steganography. I don't know if you guys have heard of steganography, the way of hiding information in images, where we can't perceive the difference between the images. But because of the small differences in the pixels and the pixel values that it shows, it can hide data. That kind of idea in terms of watermarking. Yeah. Anything else? We have 3 minutes left. Anything you want to talk to ChatGPT? One of the things I kind of wanted to do if I had more time, unfortunately I didn't, I was going to try to marry this to a text-to-speech. So thinking, oh yeah, it'd be really cool if it responded, but in Hal's voice from 2001. But,
One question.
mm-hmm.
Did you install some VS Code extension with ChatGPT or doing stuff like that?
I haven't yet, no. I know they exist, but I'm not sure how different it's going to be from Copilot. Because Copilot is ChatGPT or GPT 3.5, which is pretty much the same base that it came from. I think if you wanted to ask it to do something, then ChatGPT would basically semantically be able to convert what you had requested into code. But then in order for me to just type in, function, Dijkstra, you could probably always automatically know, hey, you're trying to do Dijkstra. Kind of like Clippy and Microsoft Word. Hey, I see you're trying to do a Dijkstra algorithm. Here's my suggestion.
I think so. It's using also like that system. I'm not quite sure because the only one I tried was not really effective. But the intention was to make some debugging on the side.
That could be interesting.
You can generate movie titles and emojis.
In emojis.
Yeah. I've been doing it.
So give me an example.
You tried
I did saw Sacred and Sing. It wasn't that funny though.
Oh, okay.
Things like Finding Nemo.
Give me...
Finding Nemo and emojis. You don't even have to have all that. Jay.
Thinking about it. What would be good? Ta-da! It's got to explain it to me. Flex the arm? What?
Yeah, the second last one.
Yeah, but why?
To be startled
They
down.
fight something? I don't know.
This could be part of the actual art class.
Yeah.
Yeah.
Yeah, they could have
drawing is the blue one, or both sides?
They could have painted this one blue and have been more accurate because it's not an actual clownfish. But that's a little bit.
That's your computer, because
pedantic.
mine has different emojis. Mine has Apple emojis.
Do it again.
With Apple emojis.
Oh, rip.
Do it again. Okay. Well, I think that's all I had. Yep. That's it. Hope you guys enjoyed. Hope it was informative. I encourage you all to get an account and play with it. If not, maybe just for the amusement of it, but also to give maybe a clue as to what you might use it for. I've heard of people using it to plan. I think this is kind of brilliant, but one of the tedious tasks for my family is, what do we eat? And so you can ask it to do a recipe for every night for this week. And you can tell it, I don't like chicken, and then it'll remove all the chicken recipes. Or, I want something spicy on Wednesday, and it'll change it up to something
You can
spicy
give
on
it your
Wednesday.
ingredients, and it'll figure
Yeah, and then it'll tell me, give me a shopping list for these, and then it'll give you the shopping list for it. So there's some, interesting things that it could be used for. Especially if it's, obviously text oriented. I don't know what to do today. Where do I go? Maybe it'll tell you stuff that's going on today. Maybe it won't. I don't know. Of course, it's constrained. It's constrained to what it has in its previous modeling, not necessarily what is going on today. So it won't tell you, hey, there's this event going on across town. Instead, it'll tell you, oh, you can go play soccer. Go play tennis. Stuff like that. But it's ideas. Good. Thanks for coming out. Afterwards, we're going to go out and have some chicken and beer. You guys are more than welcome to come join us. In fact, we highly encourage it because we try to keep this group to be as much social as possible. And if you have other questions or things you want to ask or even just discuss amongst the people here, it's a great place to do that. It's free. Another big plus, free chicken and beer, right? And if you, we do, however, ask for small donations if possible. It's not required. But if you do want to donate a little bit, this is how we fund the dinners and stuff, you can find our details on the meetup page as well as, it's not on our website yet. It's only on the meetup page. Right?
Oh, really? Okay, I'll put it.
I don't think so. I'll check right
I'm
now.
going to the codefull.org.
Oldsoul.org.
Yeah, it's not on that. We got it.
Right. And then here are some of the other events upcoming.
You want to do that?
All right, cool. Hopefully I'll see you at dinner. Chicken and beer. Maybe it's dinner, maybe it's supper. I don't know.
Can't get ChatGPT to add it.